Today we're going to talk about domain of functions. By the end of this video, you should be able to properly communicate using set and interval notation, and you should be able to state the domain of various functions. First, domain is the set of all x values that satisfy a function. We often state the domain by stating what is not included in the domain, and we call these domain restrictions. There are two different types of domain restrictions. First, any x value that makes the denominator equal to 0 is a domain restriction. And that is because we cannot divide by 0. So if you plug in a number for x and that makes the denominator equal 0, then you have a function where you are dividing by 0. So that value of x is not a part of our domain. The second domain restriction is any x value that makes the radicand of an even index radical negative. So by this, I mean if we have square root or fourth root or 12th root or any other radical with an even index, the radicand, which is the value inside the radical, cannot be negative. You're familiar with that with square roots, but it's also the same for any even indexed radical. Let's take a look at a few examples. First, we have a of x equals 4x over x squared minus 9. Since we have a fraction here, we need to be concerned about the values that make the denominator equal to 0. So we're going to find those domain restrictions by taking the denominator and setting it equal to 0. Then we need to solve for x. For this one, I'm going to factor because this is the difference of perfect squares. And then solve. So this means if I plug in either -3 or +3, I will end up dividing by 0. So these values for x cannot be a part of our domain. You should be familiar with both set and interval notation. If I'm going to write the domain for this in set notation, I would say that the domain is the set of all x values such that x does not equal positive or -3. When we write the domain in set notation, we always have curly brackets. That tells us that we're talking about a set. Then we always need to specify what the variable is, in this case x. This vertical line you read as such that, and then you give the criteria. So this means we could have all values except positive and -3. If we're going to write the domain in interval notation, we need to think about a number line. So we've got -3 here, we've got +3 here. Our domain can be everything except these two numbers. So we have this interval, which is -∞ to negative 3. Then we have this interval, which is negative 3 to positive 3. Then we have this last interval from positive 3 to infinity. As we write our domain in interval notation, you'll notice that I used parentheses. Remember that parentheses do not include the endpoints, so we can never equal positive or negative infinity because those are not actual numbers. So we're going to use a parenthesis there. And we are not including positive and negative 3 in our intervals, so I've used parentheses here. We'll see another example in a few minutes where you are including the endpoints, and we'll talk about that situation in a minute. The final thing you have to do is include these union symbols. So you would read this as negative infinity to negative 3, union, negative 3 to 3, union, 3 to infinity. The union symbols mean you are including everything that occurs in all of those intervals. So you can choose whether you prefer set notation or interval notation. That is your personal opinion, but in some circumstances, set notation might be more efficient. In other situations, interval notation might be more efficient. Let's take a look at the next example. We have b of x equals square root of 4 minus x. Since we have a radical here, and it is an even radical, we have a square root, we need to be concerned with the values that make the radicand, which is the part inside the radical, negative. So we can take the square root of positive numbers, we can take the square root of 0. So our domain is going to be every x value that makes 4 minus x greater than or equal to 0. So we just need to solve this inequality. We subtract 4 from both sides and then divide by negative 1. Remember that when you divide by a negative, you have to switch the direction of the inequality. So we have that our domain will be all x values where x is less than or equal to 4. So when we write this in set notation, we just say the set of all x values such that x is less than or equal to 4. For interval notation, if we think about our number line, we are looking at all of the x values where x is less than or equal to 4. Since we are including 4 in our interval, we are going to say that our domain is negative infinity to 4, and we're going to put a bracket on 4. So the bracket indicates that you are including that number in your interval. The next problem is c of x equals 5x plus 1. In this problem, we do not have a fraction, so we don't have a denominator to look at, and we do not have a radical. So we do not need to look at what makes the radicand negative. So this means that our domain will be all real numbers. There are a couple ways you can write all real numbers. You can just write a capital R with 2 vertical lines on the left. That stands for the set of all real numbers. Or you can write it as the set of all x's such that x is an element of the real numbers. Either way is fine. For interval notation, the way you write all real numbers is negative infinity to infinity. So you are including every number in your interval. For the last example, we have a geometry formula here. It says volume is equal to 4/3 pi r cubed. This is the volume of a sphere formula. If you notice, we have no fractions, so we don't have a denominator. Well, I mean, we do have a fraction here, but there's not a variable in the denominator. And we have no radical. But if we think about this, because it is a real-life formula, we're talking about the volume of a sphere, we have a reality restriction. This comes up a lot when you're using geometric formulas or in science class. Because we're talking about a radius, or a radius is a length, it cannot be negative. So r must be greater than or equal to 0. The radius could be 0, that means you don't have a sphere, you just have a point. Or the radius could be positive, but the radius cannot be negative. So when we write our domain in set notation, we're going to say the set of all r values such that r is greater than or equal to 0. And in interval notation, this would be going from 0 to infinity. But since we are including 0 in our domain, we need to use the square bracket on 0.